started right there. Okay, so spring semester has begun in Math 1505. So I'm taping the lectures, right, so that I can post those after class. So you'll have a tape of this Zoom meeting, and then also the class notes I will post after class as well. I'm not showing the notes here yet, but in a moment here we'll get around to the class notes. So once we've gone through all the formalities of talking about the syllabus, those will be posted as well after class on the class web page, if I can find that. And yeah, so there it is on the class web page there, under obviously where it says class notes and videos. That's where those things go. And usually it goes up in the afternoon right after class, but I don't make that a firm promise because stuff happens. But usually it doesn't take me all that long to post those things after class. I cannot post the notes prior to class, so I get that question often, and that would be convenient, but I can't post them prior to class. So because I don't know always where we're going to be at a particular instance. So so you just have to wait till after class to get the class notes posted. Okay. There are some other things that will go into the Blackboard page, but we really don't interact with the Blackboard page a lot. Okay. I do make sometime announcements there, but I will also make those on our homework platform, which is called Webassign. So I usually make announcements there more often than in Blackboard. I will, however, here later on in the semester, put sample tests. So in a moment, we'll talk about the tests, which are described in the syllabus. But sample tests for those tests, I post those prior to the test, usually a couple of weeks prior to the test, right here on the Blackboard page. Because it's not convenient to put files in Webassign. It's easier to put files on. So sample test there, and then the test answers after we've had the test. I'll post the solutions there also here on Blackboard, and that's kind of it for what goes into Blackboard notes, and then the notes and video links, and then the videos are actually in YouTube, but the links are here, and then sample tests, and then the test answers. So, and then of course the class syllabus is always there for you to look at, right? Let me go back to the class syllabus and talk about things on the class syllabus. So we're in this awkward situation, exactly like we were in August. If you were here in August when we started the fall semester, so we're right in the peak of this Omicron surge. We were in the Delta surge in August of last year. So the university is undergoing this this soft opening process. So y'all been probably being bombarded with emails about this, and things are happening in your other classes. That really does not affect us too much in this class. We were going to conduct the class the same way in any event. Okay, so so the soft opening is really inconsequential for us. The Omicron surge, of course, is going to be hopefully inconsequential as well, but we cannot tell. I expect that that's going to be receding through the course of the spring semester, like the Delta surge was receding through the course of the fall semester. I think we're past the peak, actually. And so I think things will look significantly better, cross our fingers, in about a month, okay? But in any event, we'll conduct class the same way. So you're welcome to come to class, and like you are now, face to face. But for those people online, you're welcome to continue online. Now, there is one caveat to that, though. Okay, the being on Zoom is that's really a privilege. Okay, of the class. So if you do not pass the first test with a sufficiently high score, then you're going to have to come to class. Okay, so you'll have to go off of Zoom and actually physically come to class, because that will benefit you if you did not pass the first test. So for you people who are planning to attend on Zoom, that's great. Okay, but keep in mind that you need to stay engaged, right? And do your homework and so forth, right? So that you can pass your test so that you can continue, so that you can continue on Zoom. I am trying to make sure that I duplicate for the people on Zoom what's going on in class, but I cannot do that exactly. But I will try to interact with you people online as best I can. By the way, I should point out that the chat screen, the Zoom chat screen is being broadcast here to everyone. So you're not chatting to me privately. So when you chat, be aware of that. Okay, the whole class is seeing your chats, but I do encourage you to use the chat feature if you want to, although I'm not so great always about looking at the chat screen while I'm talking. All right, so there's only so many things I can do at once, but if you're more comfortable chatting than you are responding to me verbally online, then by all means use the chat feature. But I will try to engage the people who are online, so I probably will be through the semester asking you guys questions. I'll be calling people and online and asking them questions about stuff that we're doing. So you want to stay engaged in the lecture, so you'll be prepared to answer my questions, right? If I call on you and I do not, and you don't respond, and so I think that you have disappeared, then I'm going to count you as absent. Okay, so so be aware of that. All right. Now, we do have an attendance policy, so I will be taking roll probably starting next time. So you can read about the attendance policy syllabus, okay, but there is an attendance policy that goes with the class. So I'll start taking that next time once we're certain that everyone is here who's going to be here. It's easy for me to take attendance online though, so so I'll also have your online attendance as well. Okay. So there are lots of other things here to mention about the class, but that we'll get to. But I just wanted to tell you a little bit about what the class is going to be like, right? Okay, and what this class is about. So the title of the class is really actually very descriptive of the class. It's Precalculus, and so we are going to highlight things that you are going to need to be prepared to do well in calculus. Okay. So our goal is really to make sure that you're ready to take calculus. That's such a crucial course in all of your majors that or you wouldn't be in here. So and it's also a really fun class as well. Calculus is. So so I want you to do as good as possible. Take calculus. So I'm gonna hit highlights of things that are important to know, so that you calculus. So you calculus. So some of the things that we talk about in class are going to be view of stuff that you know already, or that you have seen already or learned about already. But we're and we will review it to some extent, but we'll also going to try to deepen your knowledge a little bit. So we're going to go a little bit deeper into these topics that you already okay, and not just sort of rote things that you may learn in algebra class before you get in here, but maybe learn deeper some of rigorously some of the background things that you learned, but already learned. But then some things will be completely to you. Okay, right? So there will be some things in the class that I expect you to see. Right? This class. So so when we are reviewing things that you are familiar with, that's great. Okay. You know, I certainly want to you to recall your past knowledge of these things and utilize that. And then, but again, keep in mind, I may take it to just a little bit and more rigorous level than may have seen in prior courses, because calculus is going to be more mathematically rigorous than your prior class is going to be more mathematically rigorous than this class. So you need to be prepared for that sort of level of thought, okay, and reasoning. So I'm going to try to prepare you for that, but in the context sometimes of things that you're already familiar with. Okay, and a big piece of the course is trigonometry. So if you don't know trigonometry, then all of that is going to be, all of that will be to you, right? So that's what we're going to do in the class. We will be, of course, I'll be lecturing, so I'll have notes. So we will have lecture, but then also we will be stopping from time to time and doing activities here in class, and the same activities for the people online as well, right? And so we'll be breaking up the lecture, I hope, fairly frequently with things that I'm going to ask to do. That's why I'm passing out the paper and cards and so forth. So so be prepared for those things as well. Okay, all just me talking. 2 hours and 15 minutes of me talking. That's too much, right? So so time for to work, and I'll try to get around to everyone doing class activities. I'll try to make it around to everyone so that I can, make sure you're doing the right thing, or so that I can answer questions, about whatever questions you have about what you're doing at that particular instant. You can also interact with each other. So on class activities, you're welcome to talk to whoever's next to you, right? If you're comfortable doing that. Let me see. I'm gonna have someone just come in, so I'm gonna give them some stuff here. Paper copy of the syllabus, but again, this is posted. All of this is posted online. Okay, so we do have a book for the class. I don't really refer to the book all that often, but well, yeah, really not hardly ever. Okay, but the book, you don't have to physically purchase it, because there's an e-copy of the book that is part of the homework system. So when you purchase access to the homework system, then you'll get an e-copy of the book, and the e-copy of the book is plenty sufficient for our purposes. Okay, most of the material will be coming from, or essentially all of it will be coming from my notes. Okay, right, not from reading the book. Okay, notes and homeworks. Let me, while I'm thinking about it here, let me switch over just briefly. And some of you, 3 of you, in fact, have already registered for the homework system, which is called Webassign. Let me switch to the student view, because this is what you're going to see when you enroll in Webassign. Okay, so that's the home page that you'll be looking at, and on the left-hand side here of the page is the list of homework assignments in Webassign, and we've already got a homework assignment that's posted. Okay. But this really doesn't involve mathematics. This is all just about how you use Webassign, so how you enter and answer Webassign. Okay. So being an online homework system, and the fact that we're doing math and we have math notation, sometimes it's a little bit tricky to enter answers right or on a computer. So this homework will be a bit of practice with how to enter answers. Right, and so you can access Webassign. It's webassign.net. Okay, webassign.net is the address, and that's in the syllabus. And there is a code for the class that you need to enter to get registered. I mean, to get enrolled in this class. Okay, now Webassign does cost money, so that's the textbook cost that's associated with the class. You can, however, enroll in Webassign right now for free. So you have a 2-week grace period where you can go ahead and enroll in Webassign. So I encourage you to go ahead and enroll immediately and start working on your work. And then you don't have to pay for access for a couple of weeks. Okay. I know that the cost burdensome. I understand that. That's one issues with going to college is paying for textbooks and stuff, but this is a really integral part of the class. It's not optional. Okay, so you will have to eventually pay for access to Webassign so that you can do your. You don't have to do that for the first couple of weeks. Okay, the homework though is a really important part of the class. All right, it's really important to classroom to. Okay. If you don't then studiously, then you're not going to do well in the class. I can tell you that. Okay, so that's absolutely essential to doing well in the class. Let's actually here. Let me see if I can. An extra. Let's go to, let me see if I can type here in Webassign. And so it's webassign.net. And then I think when you start, see, it's a little bit blocked here by Zoom screens, but it says enter class key. So just click on that. And then that's where you'll enter the key that's given in the syllabus. Does anybody have their? Can y'all find that for me in the? Can y'all find that for me in the syllabus there? And let's see if we can enter that.
I have it.
It's something like this, but probably not this. What's the? Yeah. Okay, all right. So slow down a little bit though for me. 3, 6, what? 1, 0, 1944. Okay, let's see if that does anything. And I think it did, right? Okay, so that's the picture of the front of the book, which again you get an e-copy of that, right? Okay, and then just continue here, and you can continue enrolling. I'm not going to continue because if I continue, then I'm going to have to create an account or something, right? So I don't want to do that. But if you already have an account in Webassign, know you have a password, go ahead and use that username password. Okay, separate password just for this class. Okay. So again, you can go ahead and enroll, and you can start working on that very first homework assignment that I showed you there, right? Okay. This one, and we'll maybe look at this a little bit closer next time. Once more people have gotten a chance to enroll, I'll ask if y'all have any questions about this, or we'll look at some of the problems on here. But again, none of the problems on here really involve, they don't involve math that we're doing in this class. It's just practice with how to enter answers. When you are entering answers in Webassign, for this class is you get 5 submissions for each question. But after the 5th submission, unfortunately, you've lost credit for that. You cannot ask for a duplicate problem. So it's 5 submissions, and that's it. Okay. So if you've missed it a couple of times already, and you don't know what is happening, you may want to stop at that point and seek out some help. Okay. One way to do that is by failing these. So with questions, there's an ask your instructor or ask your teacher button with each question, and you can email me, and I will see a copy of the question, and you can figure out what. Okay, on that particular question. Okay, or you can seek help elsewhere as well, right? Talk about where you also on campus ask for help too. Okay, with your math questions. So, but be aware of that 5 submissions. And one other thing to be aware of, I'll try to, because it's going to come up constantly. have to read the instructions in Webassign very carefully, very carefully. Okay, read the instructions for how they want the answer entered, because it will be very picky about how the answer is entered. So it will often say 3 decimal places. And if it are 5 decimal places, sometimes that's a little bit excessive. Usually it's 2 or 3 decimal places it may want for an answer. Then you have to enter the 2 or 3 decimal places or it won't count it correct. Another thing is, doesn't say enter and answer decimals. If it doesn't say that explicitly, that means it wants the answer in exact form. Okay. So if the answer to a question is, for instance, square root 2 something, and if you were entering that in, it says enter it in decimal form to a certain number of decimal places, you would type in decimal approximation for square root, which is 1.4, etc. Okay. So, but if it doesn't say decimals, that means it wants it in exact form. So you would have to, using the tools in Webassign, have to create square root of 2. That's what it would expect as the answer, and it wouldn't take a decimal approximation in that case. This is a frequent source of problems with students entering answers in Webassign. So I just want to warn you about that. Be sure you read the instructions for how it wants the answer entered. Okay. All right. So if you would, it would be good if you would by Monday go ahead and get enrolled in the class. Again, you can do that for free, right? So in Webassign, get enrolled in the class. That gives me a way of knowing one thing that you, everyone has been here. Okay. So and it's heard these instructions. So try to get enrolled by Monday. Okay. So that we can discuss it a little bit better to do Webassign. Okay, so I forgot now the percentages in the syllabus, but your homework is what did I say in terms of your grade? That's 15%. Okay, right? Okay, so that's almost as much as a midterm test, and we're going to have 3 midterm tests. What are those? 17%? 20%? What? 60 total. Oh, so 20% each. Okay, right. So there's the 3 midterm tests, and then the rest of that, which I guess is 25% is final exam. Okay, so so we do have a comprehensive final exam at the end of the class, comprehensive, and then those 3 midterm tests, and then the homework. That's it for your grade. Okay, right. That's how your grade is formed. So that's pretty easy. But 15% of that is the homework. And so that's the portion of your grade that you have the most control over. You know, when you're taking tests, of course, you want to study for the test and be prepared for the test, right? But, you know, things happen when you take tests. Sometimes you blank out, or, you know, something you really knew. For some reason, you just don't make a trivial error on it, right? And you can't really correct it very easily on the test, right? Because you don't have enough time. So, you know, things happen on tests and you use points for reasons that really aren't a part of about how much you know about the class, right? But with your homework, because you can correct things, you can really control your grade much more closely on the homework. So you really have an opportunity to have a really high score on the homework. That's the one grade that you really, for certain, that you can have in the 90s, for instance, right? Okay, so so keep that in mind about the homework, right? Really control your score there, and it is 15% of your score. So that's just 15%. That's very easy to earn almost the entire 15%, if not the entire 15%. And then that also prepares you well for your test. So that's going to also, when you're taking the test, and ultimately the final exam. Okay, so the 3 tests will be in class. So if you're on Zoom, we will have to come to class for the test. That's the one time that for sure that you'll have to be in class physically, right? Okay, but the way we'll do this is because we still want to be concerned about social distancing, so we'll split this into 2 shifts. Half of you will take the tests for half of the class, and half of you will take it for the second half of the class, because we have 2 hours and 50 minutes, so we have plenty of time for 2 groups of people to take the test, right? Okay, so and that way we won't have so many people here packed into the room one time. Okay. Oh, one more thing I want to say about Omicron. So again, I think the situation I think is improving and will improve.
La estoy viendo aquí, es que es introducción.
Hi, Ruth. Can you turn off your microphone? Thank you. All right. So, but we probably are going to have maybe some disruptions through the semester. So I hope that doesn't happen. We didn't have any last semester, but Omicron's a little bit more likely to create breakthrough infections than Delta was. So we may have some breakthrough infections. Fortunately, however, Omicron's a lot milder than Delta, which was a pretty nasty virus, actually. But Omicron is substantially milder, so probably not serious disruptions. That's what I'm hoping for. But and for you guys, it's probably not likely to be serious at all. So maybe not even missing a class if you were to test positive. But you can certainly minimize your risk or by getting vaccinated and boosted. So if you're not vaccinated, please take the opportunity to get vaccinated. There's a vaccine lab, a clinic, I mean, on campus tomorrow, yeah, on the 20th. And if you've already vaccinated but not boosted, you should take the booster. Okay, that's really easy to do, and you can do that also tomorrow on campus on the 20th. Right. So that's my advice for how to, so that we don't have disruptions here semester in class. Okay, you do not want to have to miss a lot of class. Okay, unnecessarily, right? Math, that's really serious. That's fatal, even though it can be fatal, not to you physically, to your grade. Even though the Zoom lectures are recorded and posted, not the same as attending live, right? So here's my advice for you. Okay. Now, speaking of attendance, we do have an attendance policy, right? So I'm going to start enforcing that on Monday. So you will need to be in class, right? Zoom or physically in class. That's really important. And so, so I'm going to take roll each day, and you can have up to 4 absences, but then you violate policy. Okay, and I'll tell you what the consequences for violating the attendance policy are in just a second. But now for the online people, if you do not pass the first test, then you will have to start coming to class. And if you attend online, I will not count you as present. Okay, if I need you in class, if I ask you to come to class physically, but you're online, then I'm not going to be able to count you as present. So you're going to start violating the attendance policy, right? Okay. Now, the attendance policy is part of our extra credit system for the class. So, and that's the part of this class that's probably different from your other classes. Let's see if I can scroll down far enough here to explain the extra credit part. Okay, so in this class, you can earn what are called flux dollars. And so this is, virtual money. Think of it as cryptocurrency, maybe. And here's how you mine your flux dollars, okay? Like you mine your cryptocurrency. There are various ways you can earn flux dollars. And I keep track of them in your Webassign gradebook, so you can keep track of these. And then you spend this at the end of the semester. So if you don't violate the attendance policy, you get 5 flux dollars. Not violate the attendance policy. Then at the end of the semester, you can spend that flux dollars. Now, what $25 will buy you end of the semester are a couple of things. It can buy you some extra credit points on your midterm tests. Okay, it's $3. But it can also buy you placement of the lowest midterm with final. And this benefits a lot. Okay, in fact, it will benefit almost everyone every semester. Well, there's a score very high, but for most people, get a benefit from this. Okay, there will be at least one test for which your final higher school. Again, promise. Okay, so you want that benefit at the end of the semester when you get that. Flux dollars, so you can get that bonus semester. But there are other ways of earning flux dollars as well. Okay, so you can see the list there. If you score well enough on your midterms, you're going to earn flux dollars. Right? If you do well on your, you're going to earn semester, and also lose flux dollars. You'll see the number. See, negative. So you're going to score not well on your midterm, lose flux dollars. Now, the nice thing that you can do with the flux dollars at the end of the semester is see here. There are 3 ways to spend it. If you earn enough flux dollars, buy out of the final exam. So we have a comprehensive final exam. If you're 75 flux dollars, that's not at the final exam. Also, spend your flux dollars by buying points on your midterm. Okay, so if you have 48 flux dollars, which is pretty easy to earn, okay, you could buy 16 midterm exam points. Wow, that would raise one of your midterms by more than the final average. So that is useful. So flux dollars are very helpful, and so want to be thinking about the semester and earn flux dollars so that right, especially if you don't want to take a lot of people take final, especially comprehensive final, and so if you don't want to do that, you need 75 flux dollars. Don't have to take the final if you really think you don't want to do that. Yes. It's in Webassign, so I keep track of it. Yeah, right. Okay. One of the way of earning flux dollars is attending a tutoring session. The only tutoring session though that you can class will go into the math center. So if you go to the math center and speak with a tutor in the math center, can get $2 flux per week. Okay, so you can't go like 5 times a week. $2 per to math center, and it helps. So if you are having problems with the course, it's a good thing to go to the math center anyway. Right, it's in North 925. You can do it also virtually, but you can also go physically. Make sure that so definitely do it virtually. And there's a link to the Math Center website, webpage on the syllabus somewhere. If you look through the syllabus, there's a link to their website, and I think it's also in Webassign as well. So let me see. Let me look at the Webassign announcements over here. If you scroll down, there are announcements here on the. Yeah, there's the link to the last announcement there on the right-hand side. There's the link. So I think that link scheduled virtual as well. So have to ask questions about your homework on test review as it's coming, right? Sorts of things, but you get $12 for that. Same thing for you guys online, right? Okay, let's see. There's one other thing I wanted to say. Oh, yes. Okay. This announcement is also important. So I want to mention it again later in later when we're getting close to a homework due date. But our homeworks have due dates on them. So it's not like, all the homework is due on one day before the test. They're due through the semester. And I always display the due dates before class every time, so you'll know when homework is due. But if you do miss a due date, you can ask for an extension. It happens automatically. I do not have to approve it. And there's the process for asking for an automatic extension for your homework. The one penalty there, though, is that you will lose some points for the points you earn after the due date, not the points you got before the due date, but the points you earn after the due date. You only get 60% of those. But still, that's helpful for boosting your homework score if you missed a particular homework, right? Okay, and just follow the instructions there and you get the extension automatically. I do not have to extension. That is not necessary to go through me. Okay, so when we get closer to a homework due date, I'm going to remind you of this, but this is useful if you miss, for some reason you're busy or you just lost track of it. If you miss a homework due date, then you still don't have to have a zero, right? So that, okay. All right. Let's see. Are we able to take the final? Christopher has a question here. Are we able to take the final before spending our money? Yeah. Christopher, you were really thinking ahead. I admire that. But the answer is, no, right? Okay. I'm going to force you to spend your money before you take the final. Okay. That's I know your strategy is I'll take the final and see how I'll do, and then I'll use the money, but you cannot do that. Okay. So you have to turn in your spending request before you know what you made on the before you know what you made on the final exam. Okay. So the easy way to not worry about that is not take the final, right? And so if you earn $75, you don't have to take the final. Okay. All right. Other questions about all of that stuff? I'm sure I left something out, but yes. Yeah, you will have. Yeah, they will make you check in some way, and then I get a report on that. Yeah, so I will know the date that you went there. Yeah, of course, online, you have to log in. So, but even if you go physically, you have to check into the center. So the math center is in North 925, and the hours I think are I forgot. Okay, all right. So open on Saturday also, right? Okay. And again, I think you can schedule virtual appointments at those times as well, right? So okay. All right. So a good question. Any other? Uh-huh. Hmm? No, if your final is less than one of your 3 midterms, it's just I wouldn't penalize you by replacing one of your midterms. Yeah, right. So what that means is, unfortunately, is you just wasted some money. Okay, you cannot get back. So but the reason for that is to make sure that if you're going to take the final and do that, you want to prepare for the final. So, okay. And there'll be lots of opportunities to prepare for the final, as well as prepare for the 3 midterm tests. Okay. No more questions then? I don't think there are major things there that I need to still need to mention in syllabus. Okay, so let's before we take a break here, let's actually start. All right, so I'm going to switch to the notes. Okay, and I'm going to lower the screen here a little bit. So for you guys online, you're going to be looking up at some lights here, but I'm going to be writing on the screen, right? So That's why I'm lowering the laptop screen. It's hard for me to write on it while it's tilted. See if I can get all my wires out of the way. Okay. All right, so as I mentioned, right, I was trying to get you guys ready to do well in calculus. And so a big part of calculus is studying the geometric properties of curves, right? And of course, drawn on a two-dimensional surface, right? So here I drew some curves on a two-dimensional surface, right? There's one. Here's one that's a little bit more exotic, and there's another one that's different, right? Okay. Well, so curves like these, right? They're a big part of studying the geometric properties is a big part of calculus. So we're also going to talk a lot here about curves in this class, certain aspects of curves. Actually, we're going to learn late in the semester how this curve was generated and how this curve was generated. This one will also understand a little bit better too. This one, so to create then these two. Okay, and but to understand curves, we have to. We're going to start right back at the beginning. Okay, to understand curves, we first have to understand how we locate points on a two-dimensional surface, because curves that we're going to be studying are drawn on two-dimensional surfaces. Okay, so I'm going to start off here with a little bit of recall practice, get you to think about or to remind yourself of something that you already know. Okay, so on the on one of your index cards, save one of the index cards, leave it blank, because we're going to do something else with the second index card. But on one of the index cards, use that for writing, because we got a few of these recall practices that we're going to do. So put the other side. Something else you don't want to write on that. All right. So I want you to see if you can explain in your own words, okay, as best you remember, how to locate a point on a flat two-dimensional surface. Okay. So how do you describe the location of a point on a flat two-dimensional surface like this one? All right, okay, that's a flat, that blank part there, right, is a flat two-dimensional surface, right? So if I were telling you, I'm thinking of a point on that, a particular point, a particular location on that two-dimensional surface. All right, okay. And I told you I'm thinking of a point there, and you said, well, tell me where that is located. Right? Tell me where that point is located. How could I describe for you without pointing? Okay, I can't physically, without physically point at it, but verbally, how could I, or symbolically, how could I describe to you the location of that point so that you could point it out to me? Okay, you could say, oh, this is what. So how do you verbally or symbolically, not physically, but how do you verbally and symbolically describe the location of a point on a two-dimensional surface? There's actually multiple ways of doing this, but there's one that I'm sure you have already learned. It's the one that I'm thinking you're going to try to describe to, right? Okay. Okay. But there are many ways actually to come up with a way, then that would be interesting. Going to learn other ways later in the semester for locating points on two-dimensional surfaces. All right, so are y'all just writing something down? So just take a few minutes there. You guys at home, same thing. All right, so you can see that blank two-dimensional, flat two-dimensional surface there. How would you? What system could you use? What system? That's a good word. Or what method could you use to locate a point, just, or I should say, describe the location of a point on that two-dimensional surface. Yeah, I could actually put a point on that two-dimensional surface. There's a point. I said describe the location of that point on that two-dimensional surface. You do that in words or in some sort of symbols or notation. Don't worry about trying to write things down perfectly correctly. Okay, I'm just trying to get all you need to be able on looking for here is for you to try to recall, right, what you already know about this problem. Okay, so any words that you use, even if they feel like they only make sense to you, or you know they're kind of jumbled up, that's okay. I'm going to cheat a little bit here. Let me move this point up. Make it easier for me in a moment. Put it there. Okay. All right. Doesn't matter where I put. And you guys writing something down? Did y'all write something down? I wrote less than what I thought you would. All right, so several. Now I may ask you to share, all right? Okay. So so you have to be prepared for that. And I'm kind of cold-blooded, so I might just call on someone at random and ask. That may happen through the semester, by the way. I'm sometimes prone to cold calling, right? So I don't do it to be cruel. So there's a reason for it. But I will try to give you fair warning. Okay. Looks like most people have written something down. You guys at home, did y'all write something down? Yes. I'm not hearing anything.
Yes, sir.
Okay. All right. So we got one response, or you can chat in also if you just wanted to say yes through the chat. All right. So someone in the class, I'll start with someone in the class. I want someone to share. Can you share with me, if you're comfortable sharing with me, what you wrote on your card? You may have to offer some additional explanation. Stand it. So it's Ahmad, right? Ahmad. Okay.
So, might be as the approximation, middle,
Okay, so all right, so tell me, using that idea, how would you describe the location of this point?
So let's say we're going middle.
From the middle, so
That's our center.
oh, so all right, so I'm going to do this a lot. Touch the screen. Okay, so so you're saying put here put a point there in what you're calling the middle. So you're putting a fixed point onto the surface, all right, and that you're calling the middle. But that actually that point that fixed point we really could have put anywhere. I think it doesn't really have to be in the middle. Okay, and then what are you going to do from there, Ahmad?
I could draw a line, approximation, any measurement, valid. This
Uh-huh. So when you say use any measurement that's valid, what are you measuring though?
is
Distance from,
that point to the other.
oh, okay, all right. So you're gonna say, here's the, from the middle point, right? You're gonna measure the distance from your given point to that, that middle point. And then you're gonna say that is how you find, or that's how you locate that given point. Okay, so let's just pretend here that this turns out to be 5, right? I'm just making up a number. So you would say, okay, so to locate the point that you're thinking of, Dr. Waller, you're going to move 5 units away from the middle point, and that's how you find the given. There's all, oh yeah, see, that's the problem, right? Because I could also move 5 in this direction, and that would take me to different point, right? Okay. Or of course I can move 5 in lots of other directions, infinitely, in fact, many other directions, right? That would take me to another point. So just giving me this number distance is not sufficient to locate that point, right? After we've selected the middle, right? I think that's a good idea though, was to select that middle point, okay? But then once you've selected the middle point and you put that on the surface, right? You can't just completely describe the location of any other point just by giving distance, okay? Because it depends on the direction away from the middle point, okay? So, oh, I see. So you're going to say also specify an angle, right? Okay, the angle. Now, with an angle, though, we need to create an angle, though, need what? See, when you draw an angle, what does an angle look like? What does an angle look like? Yeah, well, yeah, so there's an angle drawn, right? But what did I need to create that angle? I needed 2 lines, right? Yeah, okay. See, it's 2 lines that form an angle, right? Okay, so if you start talking about angle measurement, you're going to have to introduce now also here on your surface, in addition to the middle point, you're also going to have to introduce some lines, okay, right? So I got to have some lines drawn in here, Ahmad. Any suggestion on drawing a line?
Can that be like X and Y axis?
Okay, so who's talking there?
Mauricio.
Mauricio, yeah, Mauricio. So you have a different. I think you have a different method in mind. Okay.
Yeah.
So let's get back to that in just a second. Okay. But I'm trying to explore Ahmad's method a little bit better. So Ahmad, we have to have some lines here. Okay. So I'm just suggesting drawing a line. I guess the easy line to draw would be just a vertical line. So in addition to our middle point, we have to have a horizontal line. It's the easiest I can find. All right. So in addition to our middle point, if we're going to create angles, we also have to have some lines drawn. Okay. So I'm going to draw here a horizontal line. I'm going to put it through the middle point. I guess I didn't really have to put it through the middle point. Put it through the middle point. And now I do see an angle here, right? Okay. There is an angle now, right? Okay. So here we have this angle formed from this horizontal line and this line, which was just this line I drew from the middle point to my given point, right? Okay. But then I have to measure that angle. Okay. But I think now you've sort of hit upon a system there, right? Okay. you would have a distance, the distance from your given point to some middle point, but then we also need an angle, right? Okay, because that point could go in lots of different directions. Actually, that system that you sort of partially described there, that is a system we're going to use, but not immediately. So we are going to use a system very similar to what you just said for locating points on two-dimensional surfaces, but not immediately. Okay. This system, by the way, is called the polar coordinate system, right? And it's a system for locating points on two-dimensional surfaces. And it's a very important and popular system. Okay. It's used a lot, okay, in many different applications, right? But it's probably not the first method you learn, okay, for locating points on two-dimensional surface. So Mauricio, back to you. You said something different, all right? So what did you write down? I'm gonna have
I
to
put
write some of this.
an X and Y axis. That way I use the
All right, so wait, so I need to know though, you need to tell me what that is. So X and Y axis. What is that?
I put a X-axis on top of the point.
Okay, but Mauricio, what do you mean by an X-axis? What is that? What is an X-axis?
I'm confused.
Can someone else tell Mauricio what an X-axis is? It's just what? It's a horizontal line, right? Yeah, it's a horizontal line, right, Mauricio?
Okay.
It's not just any old horizontal line, though, Mauricio. An X-axis is a horizontal number line. All right. So
Yes.
an X-axis is a horizontal number line. So let's mark off this X-axis with numbers. Okay. Like we do a number line, right? Of course, zero's got to be somewhere there. And let's put our other numbers on our number line. So we did that. Now what else?
The Y-axis,
What's that?
the vertical line.
That's a
vertical line.
vertical number line. Okay, so I'm going to draw a vertical number line. Where do you want to draw that vertical number line?
I put it at 0.
Oh, you put it so it goes through right here?
Yeah.
Okay,
Yes.
so let's do that. So this also, darn it. Bad about touching the screen sometimes. All right, so that also goes through. And see, that also is a number line, so I'm going to mark that off with tick marks here for my numbers. Whoops. Make this positive. All right, now keep going, Mauricio.
And then I didn't go that far into putting numbers, so I just said that it was in quadrant 4. But you can say it's on.
So how do I locate that point though?
-1.
What now?
With the numbers, with the number lines.
So you do what with the number lines? What do we do with the number lines? I'll help Mauricio with what we do with the number lines.
I guess try to
Find
connect
the
to the
location
point.
of that point. What do we do? Okay, so you give its location with respect to the x-axis, and you give its location with respect to the y-axis, right? Okay, so
Yeah.
where is that point located relative to the x-axis? That looks like at what?
Look at 2.5.
2.5 maybe?
Yes, maybe.
Yeah, that's probably close enough. And then at here, I didn't draw the axes very well, right? That looks like that's at what?
-0.8, 0.9.
Minus 0.8 maybe?
Yes.
So you give its position with respect to the x-axis, right, or horizontal axis, 2.5, and then you give the position relative to the y-axis, looks like at minus 0.8, right? Okay.
Yes.
And those two numbers there are called the coordinates of that point. Okay. all right, so this is another system for locating points on two-dimensional surface. This is the one that you're most familiar with, I'm sure. Y'all know what this system is called, where we draw these perpendicular axes like this, a x-axis and a y-axis, and then we give a position of a point relative to those two axes. Y'all know what that's called? What? So what's the name for this method that we just practiced? Anybody know that?
Linear graphing?
What now?
Linear graphing?
Not linear graphing, okay? Just but we will talk about what linear graphing means soon here, okay? But just this whole idea of drawing these two set of axes, as you called them, and then locating a position of a point with respect to the two axes. But that whole system has a name.
Is it coordinate system?
It is coordinate system, but a coordinate system is any system for locating a point on a two-dimensional surface, including a mod system. So this coordinate system has one other title that goes with it. I know what that is. Well, often it's called the rectangular coordinate system. That's one thing that it's called. A mod system that he described also was a coordinate system. I mentioned that's called the polar coordinate system. Okay, slightly different system. There's another name for this also. This is also called sometimes the Cartesian coordinate system, because that is named after the French mathematician Descartes, who was credited with inventing this system, believe it or not. Okay, so Descartes is given credit. Seems like a very intuitive, easy thing to devise, right? Okay, but Descartes is given credit with sort of may not have been the first one to devise it, but he certainly explored it a lot more than earlier people had. Okay, so Cartesian coordinate system also. There's a famous apocryphal story about Descartes and the Cartesian coordinate system. So Descartes was daydreaming at some point on a rainy day, and he was looking out the window, and you know how these this was a long time ago, right? So old-fashioned window had panes in it, right? Okay, and so and it was raining, so Descartes was looking at the raindrops falling on the window, which is a two-dimensional surface, right? But the window had these different panes, and so the panes sort of acted like the axes, right? And Descartes realized, oh, I can describe where a raindrop falls on the window. I can locate it, the raindrop, by giving its relative position to these panes, right? Okay, so that's probably not a right. So sounds good, right? That's how Descartes devised the Cartesian coordinate system. Okay, all right. So y'all are all familiar with that, okay? You knew that, right? Okay. But maybe we're thrown off a little bit about what the question was I was asking. This is so familiar to you, okay? Right? Okay. All right. So that Cartesian coordinate system, right, is the one we're going to start with and using that we're going to use to locate points on two-dimensional surfaces, right? Notice it takes two numbers to give the position of a point on this two-dimensional surface. Okay. And that is something that's okay. That fact that it takes two numbers to locate a point on a two-dimensional surface, that's something that's very and connected to the shape and the nature of our universe, right? Okay, takes two numbers to locate a point on a two-dimensional surface. Okay, Ahmad, that's why you were struggling when we were first talking about your polar coordinate system. You left off the angle, right? Okay, but you cannot leave that off. It takes two numbers always to locate a point on a two-dimensional surface. Okay, all right, that's sort of what makes a surface two-dimensional, right? is that fact. Okay, now we're going to take a little bit of a brief break here, and then we're going to go back and fill in some geometry, geometric facts. Let's say, not really geometry, geometric facts here about points and our Cartesian coordinate system, right? Okay. And the first little bit of geometry we want to establish here is how do we determine the distance between points on two-dimensional surfaces, right, in the Cartesian coordinate system. Okay, so you've done this before, all right? So we just want to remind ourselves of how we do that. Okay. All right. So, but now we're going to take a break. So I'm going to pause the tape here for a second. Right. And so we can go outside and get a drink of water. Let's resume the recording now here and look at this particular problem. So there we have 3 points, right? Located on our rectangular coordinate system. So here I've drawn my axes, right? There's my vertical axis, right, which is normally labeled Y, correct? And then we have the horizontal axis drawn here, which is normally labeled X. And then there are my 3 points, right? And with their coordinates indicated. And I've also given just capital letter names to these 3 points so that I can refer to them kind of easily without having to always just give the coordinates. So the question here, though, is which of these 2 points, P and Q, is closer to this this point A? Okay, so is it the point with coordinates 1, -2? Is that closer, or is it the point with coordinates 8, 8? Is that the one that's closer? By the way, now when as I think was it Mauricio mentioned that normally when we're drawing the axes, the X and the Y axes, right, we will draw them so they intersect at 0 on both number lines. That point where the 2 axes intersect each other, that point is called the origin. But it doesn't have to be drawn so that the coordinates of the origin are 0, 0. That's just normal, but you don't have to draw it that way. You can really position the horizontal and vertical axes any way you like, and wherever they cross each other, whatever the coordinates of that point happen to be, that's called the origin. All right, but most of the time we'll draw the axes so that the origin is at coordinates 0, 0, right? And you know, of course, when you write down this pair of numbers, this first number, the location along the x-axis, is often called the x-coordinate, and then the location along the y-axis is often called the y-coordinate. But you can also call this the first coordinate and this the second coordinate as well. Okay. All right, so just a reminder of that, just a little reminder of that terminology. All right, so so how do we figure out which of these 2 points is? I'm going to have to erase this now. So how do we figure out which of these 2 points is closer to the point 5, 3? Here. Well, so that means we have to be able to calculate distance, correct? Right? And then compare those distances. So I need to figure out what this distance is from point P to point A, right? And then likewise, right, I need to figure out what this distance is from point A to point Q. All right, so to do this now, we're going to rely on one of our favorite theorems from geometry. So this is one of the oldest theorems from geometry, but also one of the most useful from two-dimensional geometry, I should say. And it involves a right triangle. So remember, a right triangle is a triangle. Okay, so that's just you know, a figure, right, that has three straight line sides to it, right? And but in a right triangle, one of the angles that's formed by the three sides, right, is a 90-degree angle, a right angle. Okay, and so here's a picture of a right triangle, right? It has a 90 angle in it. And so I've labeled here the three sides. The two shorter sides I labeled A and B. And then the side across from, in a right triangle, the side across from the 90-degree angle is always going to be the longest side. I've labeled this one C. Okay. Remember, in a right triangle, the length of the longest side is called the hypotenuse. No, let me not say that. The longest side is called the hypotenuse. All right. Okay. And of course, it has a length, right? So in this picture, that hypotenuse I've labeled C. And what the Pythagorean theorem says, so this theorem dates way back, okay, really to pre-recorded history. This theorem has been around for a long time, so so it's not really known where it originated, but it's credited to the Greek mathematician Pythagoras. So Pythagoras was working in like around 550 BC. So this goes back a long time, but it was certainly known before Pythagoras. Okay, it's just his name is attached to it. So of course, what the theorem says, right? So you're familiar with this, is that a squared, right? If you take the plus b squared, if you take the sums of the squares of the shorter two sides, right? That's equal to the square of the length of the hypotenuse, right? The square of the longer side. Right? That's the very famous. That's a very famous Pythagorean theorem. So that's one of our most useful facts from two-dimensional geometry. Okay, is this theorem. Now, to apply the Pythagorean, actually here at the end of the class, we're going to demonstrate for you a proof of the Pythagorean theorem. This theorem is correct. It's very easy to demonstrate why the Pythagorean theorem is true. So why it's true for right triangles, that the squares of the lengths of the shorter two sides, a squared plus b squared is c squared. Right. Since we're going to be using this theorem a lot, I mean a lot in this class. Okay, it's going to be good for us to know why it's correct. Okay, so I'm going to show you that at the end of the class. All right, but now before we get to that, though, let's just actually use the theorem in this particular situation. So to use the Pythagorean theorem, I need some right triangles. So I'm going to have to draw some right triangles into this picture, right? Okay. And so here's where I'm going to draw them. I'm going to attach a right triangle here, or I'm going to superimpose a right triangle here between the points A and E. Okay. So I'm going to draw a horizontal line there from P over to the right, and then a vertical line up, right, from this position up to okay. And you know, when I do that, of course, when I put a horizontal line and a vertical line together, I get a right triangle, because this is going to be a 90-degree angle, right? And I'm going to do the same thing here for A and Q. So I'm going to superimpose a right triangle here. Now, the reason I've done that is because, well, because now I can use the Pythagorean theorem, right? Once I've got some right triangles drawn in here. Now, the reason that the Pythagorean theorem is useful here is because notice that the hypotenuse here, right, or the length of this hypotenuse of this right triangle happens to be the distance between P and A, right? And that's what I'm really interested in. Okay, and of course, the length of the hypotenuse here in this right triangle happens to be distance from A to Q, right? Which I also need to know. So, if I can find the lengths of these two hypotenuses, right, and I can compare them, then I'll be able to answer my original question. All right, so let's apply the Pythagorean theorem to this bottom right triangle, right, and see if we can figure out what the length of this hypotenuse is, right? Let me call that C sub 1 instead of just C, because I have another C here, right? And I don't want to use the letter C twice. So let me put a C subscript on it. And I'll call this length A sub 1, And let's call this vertical length B sub 1, because I'm going to have an A sub 2 and a B sub 2 and a C sub 2 as well, right? In the top triangle. All right, so what we know from the Pythagorean theorem is that if you take A sub 1 and square it and add in B sub 1 squared, right, you're going to get C sub 1 squared, right? Okay. Now, at this point, I don't know either A sub 1 or B sub 1 or C sub 1. So this equation is nice, but it's not very helpful at this point. But I can easily measure A sub 1. What is A sub 1? What'd you say there? 4? Yeah, it's 4 because I can just count it, right? Okay. I'm starting at this point and going over directly beneath this point. So on the, is it 4? Oh, yeah. I'm sorry. I was reading the wrong numbers there. So I'm starting at 1 on the x-axis, right? At point P, and I'm going over to 5 on the x-axis because that's where point A is located, right? Right. Well, if you're going from 1 to 5, you've obviously gone a distance of 4, right? So you know this length is 4. This length is easy to measure, by the way, because it's horizontal. You know, horizontal lengths are easier to count off, right? And vertical lengths are easier to measure too. Okay. This length was hard to measure because it wasn't horizontal or vertical, right? So A sub 1 there is 4. So I can fill that into my equation. So I have 4 squared. What about B sub 1? Well, that's just easy, right? I'm starting down here on the y-axis at what? -2, and I'm going up to 3 on the y-axis. So what's that distance? 5, right? So you know B sub 1 is 5. Now you don't know C sub 1, right, yet, but now we're going to find it because now we can solve this equation easily for C sub 1, right? So now we're going to use a little bit of algebra, right? Really, mostly. But so let's see. So we have 16 plus 25 is equal to C sub 1 squared, and 16 plus 25, well, that's not the most convenient number in the world, but there it is, it's 41, right? Squared. And so how do I find C sub 1? Yeah, sure, take the square root, right? So you know C sub 1 is going to be the square root of 41. 41, unfortunately, is not a perfect square. So I can't simplify this perfectly. So I'll have to use my calculator to get an estimate, right? Somebody have their calculator handy? Approximately what is the square root of 41? It's going to be somewhere between 6 and 7. I'm going to guess 6.42. What is it? Oh, I'm good. I really didn't know that. So 6.403. Let me round it off to a couple of decimal places. So I'll say 6.40. So there's what C sub 1 is. And now we're going to play, of course, the same game, right? To figure out what this, what the length of this hypotenuse is. So let me call that C sub 2. And I'll call this A sub 2. And I'll call this B sub 2. And we still have a right triangle though. So A sub 2 squared plus B sub 2 squared is equal to C sub 2 squared. And now you just have to fill in A sub 2 and B sub 2 and then solve for C sub 2, right? Can y'all do that for me? So I want y'all to try that on your index card there, right? Okay, just fill in those numbers for me. Don't, no, not too quickly. All right, let's let everyone do it. And then you have to tell me. Sorry. I know it's not that hard. Y'all doing that also at home there, right? Okay. Just trying to finish this problem off, right, by finding C sub 2. So what's A sub 2 and what's B sub 2? And then use that to find C sub 2. Okay. Oh, well, next is fine. All right, so pretty easy. Right, so that was pretty fast. Someone at home there, just describe to me, if you would, what I need to fill in here into this equation to solve for C sub 2. What is A sub 2, for instance? So someone online there, just tell me that. What was A sub 2? What is this distance? 3. And so we're squaring that plus B sub 2. What was that distance?
5 squared.
5, right? Squaring that, and then that is C sub 2 squared, right? So we have 9 plus 25 is equal to C sub 2 squared, or 34 is equal to C sub 2 squared, and then running out of room here, so let me look it up here. So we get that C sub 2 is the square root of 34, right? Which is approximately, when I put that little squiggly, that's what I use for approximately to. So what's a decimal approximation for square root of 34? A couple of decimal places is plenty, right? What, 5 point something? 5.83. Okay. All right. So so we know it, right? It's the answer is point Q, correct? That's the closer point to the point A, right? Of these 2 points. Q is the closer point, right? Because this distance is just slightly less, not much, but just slightly less than this distance from A to P. Now, that brings up the question of, this is a specific example, but that brings up the question of, in general, how do we compute the distance between 2 points on a rectangular coordinate system, right? So suppose you have 2 points, but I'm not going to specify the exact coordinates of the points. I want to leave those coordinates as variables. So I'm going to show the coordinates of this point as x sub 1, y sub 1. So these could be any 2 x and y coordinates. And then we have this second point, and I'm going to call it x. I'm going to call its coordinates x sub 2, y sub 2, right? Okay. But this is a variable point, right? This could be any coordinates that I pick. And then how do I find this distance between these 2 points, right? Okay. So so let's see. So we just found distance between actually a couple of pairs of points just a moment ago. Let's see if we can replicate that process now in this picture, okay, where I don't write down specific values for x1, y1, and x2, y2. But I want to go through the same process of computing this distance. Which here I'm calling D instead of C, right? D for distance. Because if I can go through that process with these variable coordinates, what I will have created is a formula that I can apply to any 2 points at all. Okay, so I can just reuse that formula over and over again whenever I want to compute the distance between the 2 points. Okay, so this is where algebra is really useful. All right, we're going to do some arithmetic here, or some math with these variable coordinate points. You know, while doing arithmetic with variables, that's what algebra is all about. And in this case, that algebra is going to help me create a nice formula that I can use for always finding distance between 2 points. All right, so let's go through that process again that we did in the prior problem. I'm going to superimpose here a right triangle, right? Okay, connecting these 2 points. So let me draw just a horizontal line from the bottom point over, right, until I get beneath the second point, and then we're going to draw a vertical line up there, right? And so what I have here now is a right triangle, right? So it has the lengths of the 2 shorter sides. I can call this one A, and I can call this one B. And, you know, normally I would call that one C, but here I'm going to leave it D for distance. And so by the Pythagorean theorem, we know what? That A squared plus B squared is equal to, in this case, D squared, right? Since D is the length of the hypotenuse. All I have to do is figure out what is A and what is B. Okay, so I'm going to have to do some arithmetic here, but I'm going to have to do it with variables, right? Okay, I'm going to have to do it with variables. So this length A is the distance from this point to this point along the x-axis, right? In other words, it's the distance between x1 on the x-axis and x2 on the x-axis. Now, what's the distance between x1 and x2? How can I calculate that? What? There you go, right. Just take x2 minus x1, right? So we can't really count over here, right, from x1 to x2 like we did in the previous picture. We don't know what x1 and x2 are exactly, right? But we can still calculate this horizontal length. It's x2 minus x1, all right? So A, indeed, is put it in the right spot here. So you said that beautifully. Sometimes I have to struggle with classes to see this, but you said it beautifully. A is x2 minus x1. You just have to take this coordinate minus this coordinate, and that will give you that. Okay. And then likewise, what would be B? That's also pretty obvious then. It would be what? There you go. It's y2 minus y1. So now we can fill those values into the equation. So we have x2 minus x1 squared plus y2 minus y1 squared is equal to d squared. And now how do I solve for d? Take the square root, sure. So you get d is the square root of all of this. And there you have it. That's the famous distance formula that you can use to calculate the distance between any 2 points in a rectangular coordinate system. It has to be a rectangular coordinate system, right? Okay. You can use this formula. Do y'all remember that formula? I know you've used it. Okay. So there's the famous distance. So that's one of our more useful formulas from two-dimensional geometry. Okay, is that? Well, if you never knew why that formula was correct, okay, now you do, right? It's just an easy consequence of what? What theorem really is driving all of this? Yeah, just the Pythagorean theorem, right? It's just an application, easy application of the Pythagorean. Okay. Now here's another important geometric formula for rectangular geometry, two-dimensional geometry. Okay, that's also going to be useful to us. Sometimes we also need to know the point that's halfway between 2 given points. Okay, that's called the midpoint of the. So I've just drawn a picture of this here, okay? But this is a general picture because I haven't actually specified exact coordinates here for these 2 points, right? So I've just written down variable coordinates because what we're after here is a general formula we can use to find the midpoint, the point that's halfway between 2 given points. midpoints, okay? When I say find the midpoint, I mean find the coordinates of that point, right? Okay. All right, so there's my situation, right? I'm given these 2 points. I know these 2 points, okay? And I want to find what the coordinates are of the midpoint. That's the point that's halfway between. That's the point that's halfway between 2 points. Okay. All right. Now, even though this point is exactly halfway between these 2 points, that sounds like we're going to be computing a distance, but we're not really going to distance here. All right. We are, however, going to draw some right triangles in this picture, but I'm not going to use the Pythagorean theorem. Okay, so the Pythagorean theorem is not going to come into play here, even though I want to use, even though I'm going to draw some right triangles. So we use triangles for things other than the Pythagorean theorem. Okay. All right, so there's a triangle that I've drawn in, and here's another triangle that I've. Now, these are both right triangles, though, okay? Because, you know, they have a horizontal side and a vertical side, right? So they're both right triangles, right? So that's kind of important to realize that they're both right triangles, but it's not because of the Pythagorean theorem. Now, this distance and this distance, however, are supposed to be the same, okay? This distance and this distance are supposed to be the same because this is the midpoint between these 2 points, right? Okay, so you know whatever this distance is and this distance, they're equal. So let me call this distance C, since that's the hypotenuse of a right triangle, C. So what goes here then? What? C, right, because these 2 things have to be the same. Those 2 distances have to be. Now, these are both right triangles, and this side are equal. And guess what? Since by the way these triangles are drawn, that means that all of these angles are really the same. This angle and this angle are equal, and this angle and this angle are equal. This side and this side are equal. So guess what? These 2 triangles are really what? They're really identical to each other, right? Okay, they're really identical. Okay, they're really the same triangle. I just took this triangle and sort of slid it up there, right? To form the second triangle. When 2 triangles are identical to each other, they're called congruent. Okay, that's the official terminology. So these 2 triangles are really congruent to each other. Okay, they have the same angles. Okay, and they really have the same sides as well. Okay, since they have the same angles and these 2 sides are the same, these sides must be the same as well. So if I put A here, guess what goes here? A. And if I put B here, then B also goes here as well. Okay, really have just 2 congruent, 2 identical triangles there. Okay. Now, let's see if we can calculate what A is, though, right? Little a, okay? So what is this length? Let's see. So this is x1, right? And this is, I don't know. So I just have to put x there, right? And this is x2, correct? So this length A, if we look at the first triangle, would be what? Y'all told me what? Just what? It's x minus x1, correct? Right? You just take the difference in the x coordinates. So A is equal to minus x1, right? X minus x. But this A is the same. How could you calculate this A? Look at these 2. It must be what? What's this horizontal length? What? Minus x. So a second way of calculating x2 minus x, right? Just the difference in these two x coordinates. But of course, a has to be equal to itself, right? Because that's the same a. So look what you get here. You get x minus x1 is equal to x2 minus x. Can y'all solve that equation for x for me? Solve this equation for x. I want to know what is x equal to, right? So solve that equation for x. Careful now. X is not excellent. X, make sure you're tracking. Solve that equation for x. Can y'all see that at home? Okay. So I've got this equation. Came just from looking at this picture. I want to know what is x equal to. Solve that equation for x. So you got to move some terms around, right? And solve for x. Okay, someone solve that for x. To get something for x. Okay, you have to describe to me now how to do this though. So what I'm sorry, what is your name?
Got it.
John?
Got it.
Judd? Okay.
So I work x, x, x plus.
All right, so you moved this x, this minus x to the left, and you move the minus x1 to the right. Is that it? Yeah. So you got on the left-hand side, you got x plus x is equal to, and then on the right-hand side, you got positive x1, right?
Yeah.
Plus x2, right? Yeah. Now it's kind of obvious because what's x plus x? Yeah, that's better known as 2x, right? So you have 2x is equal to x1 plus x2, and then just x is what? That's 2x, so what's x?
X is.
Yeah, there you go, right, there it is. X1 plus x2 divided by 2. So there's the x coordinate of your midpoint, okay? You just take the x coordinates of the 2 points that you're given, add them together and divide by 2. That's better known as averaging. Add two numbers and divide by 2, that's called averaging. So you just average your two x coordinates, right? And that gives you x coordinate of your midpoint. Well, we can use the same logic here to calculate what y is, and you're going to get that y is equal to y1 plus y2 divided by 2. So this is the midpoint formula, okay? If you want to find the midpoint between two given points, the point that's halfway between two given points, you average the x coordinates of your 2 points and average the y coordinates of your 2 points, and that gives you coordinates of your midpoint, right? So that's another famous geometry formula from rectangular coordinates, okay? There's how you find midpoint, right? Just average the x coordinates and the y coordinates of two given. All right, so let's recap today. We reminded ourselves here of the rectangular coordinate system, right? Okay, how we locate points on a two-dimensional surface, one way is by using rectangular coordinates, right? So that involves a horizontal axis, usually called the x-axis, right? And a vertical axis, usually called the y-axis, right? And we locate the point by giving just the relative locations of that point with respect to the two axes, correct? Okay, so you get two numbers there called the coordinates of the point. First number is the x coordinate or the first coordinate. The second number is the y coordinate or the second coordinate. Remember, wherever your two axes cross each other, that point is called the origin of the coordinate system, but it does not have to be at 0, 0. Not have to draw your axes so they cross each other at 0. But wherever they do cross is called origin. And then we reminded ourselves of the distance formula, right? That we can use to calculate the distance between two given points. And then we reminded ourselves here of the midpoint formula, right? How we find the point that's halfway between two given points. Probably never saw a proof of the midpoint formula, but okay, so now you know where the midpoint actually comes from, right? Okay, it's just about right triangles, right? Is all. Now, one other piece of terminology that we mentioned, but we just sort of mentioned it very quickly, is when two triangles are equal or identical, they're called, okay, triangles that are identical to each other, which means they have the same angles and the lengths of the sides are the same. They have to be completely identical. They're called congruent, okay? We're also going to talk about next time about triangles that are similar to each other. Similar, that's an actual math term, but not similar triangles have angles, but the sides don't have to be the same. Okay, and actually similar triangles are more useful to us than congruent triangles are. We're going to run similar triangles a lot more than we will congruent triangles. Okay, but we'll bring that up on Monday, okay, and talk about why similar triangles are useful. All right, I want to finish here now by I promised I would show you, demonstrate for you, prove for you the Pythagorean theorem, because we're going to use that so much in the class. Really need to know why that is true. Okay, all right, guys, for you guys at home, I'm going to, if I can pull this off, I'm going to switch. I'm going to switch to my phone, okay? And so, so I'm going to stop this screen sharing, okay? And I'm going to try to switch here, phone, show you what I'm showing the class on the phone. We go to the document. All right. Soft. Worked for me this morning, but let's see. All right, guys, I'm going to switch to my phone.